equations. If n is 3, now let's just write down the 3 equations explicitly. Now, this is so in part A, n is 3, right? Then you start with the n equation. So it's a small n equation. So dn3 dt is lambda 2 and n sub 2, right? That is 2. And dn2 is already given to you, and dn2 and dn1 already given to you. So yeah, 3 equations. And n1 is right, 3 equations. And then obviously to solve for all these capital N function and subject to the initial condition. N1 0 is n sub 0, n sub 2 is 0, is 0, right? And to solve it, I mean, obviously you can solve it by the usual differential equation method. You just write down the general solution and then fit the initial condition. But for us, for the using Laplace transform, right? So you can transform all this to Laplace transform. So how do we define the variables s? N sub 1, what should we call that? The transform. We already use the n, so little n. Usually we change the little n. Well, that's fine because this is just indicating any number. So you already fixed n equals to 3. That's fine. So n for the Laplace transform should be n sub 1 as a function of s. Right? And minus n, the initial condition, right? Initial condition should be n0, right? I mean, I'm working on this equation, the last equation. That equation is number 1. And that's the transform variable. So you have a you define your you can write and basically n1 is equal to infinity and 1t e to the minus d dt, right? That's the Laplace transform. So s is the transform variable, right? Is that okay? Right? This is what I call it. That's what I said. What should I use for the transform variable? I just changed that to little n. So if you don't like, you can use another variable. It's just a notation. It's okay. You can call it whatever you want. I just call this transform, the Laplace transform as little n. It's just just a choice. It's okay. Yeah. But now you can keep doing it. So the second equation is n2 similarly as a function of s. Let's get rid of all the dependence. You know these are function of s. Minus n2 0, which is 0, equals to 1 minus 2 and 2. and then S and 3. Again, the initial condition is 0. Lambda 2, lambda 2, and 2. Right? And this becomes an algebraic equation, and then hopefully you can solve it. Three equations, three unknowns. How do we solve it? N sub 1 should be trivial, right? Because you combine the two that you find. N sub 1 equals to N0 divided by, combining the two is S plus right? Now with that, N sub 2 can be solved in terms of N sub 1. N sub 2 is 1 over lambda 2, right? Oh, no. You have another answer. Okay. It's actually lambda 1 and 1 divided by S plus 2, right? And that equals to, we substitute this into that. 0, S plus 2, right? Is that okay? And N sub 3 is, now it's lambda 2 over S times N sub 2, which is this one. Let's see. Plus 2, plus 1. Right? Now you have all the transform. The way to do it is to look up the inverse transform, right? And it's okay, up to here. Okay, okay, so look up the inverse transform. So look up the table, and that would be the other table. Yeah, table 20.1. So this one should be the item for S shifted by the value K, you put it into the K. So this implies N0, that becomes a minus of this minus. Well, this is just by looking up the table. Is that okay? You know what I'm doing? This you look up table 20.1, and item 4 will have this form, right? Other than the constant, you just multiply with a constant, and you just look up the form, and this would be a minus case of 1. So just the function will be case of 1t, so minus lambda of 1t. Is that okay? All right, and now the second one is slightly more complicated. And I suppose we could do it by partial fraction, right? Hopefully that can be done. So, the constant and unknown coefficient s divided by s plus lambda 2 plus another term divided by s plus lambda 1. And this term combines to give you 1, right? And when you're combining that, you multiply this in the numerator, and then plus something multiplied by this term, and you want to cancel s, right? You want to cancel s, so whatever So each multiplied by the same thing. So it must be something. Say if it's A, this would be minus A, right? And then I probably should write down the equation. So A times lambda 1 minus lambda 2 will give you 1. So A would be lambda 1, 1 over lambda 1 minus lambda 2. Yeah, right. So that would be lambda 1, 2, 1. Right. That will cancel S. Yeah, divide by that. Okay. And now using the same table that then this implies two terms. Yeah, let's just keep writing it. And sub 2 is all the coefficient is 1. Obviously, I assume lambda 1 not equals to lambda 2, right? Otherwise, you need to take a limit of that. And then the first term is e to the minus lambda 2t. Second one is e. Right? Is that it? Well, the next one will be even more complicated, right? Because you have three factor. Anyone has done it. So this is your overall coefficient number 2, number 1, and sub 0. Three terms, right? You have S term. Don't know the coefficient yet. That's number 2. Yeah. Yeah. Right. And this one will give you a constant term, so according to the tables, because it's S plus 0, so its exponential of 0 is 1. It's a constant term. And then now you need to figure out the I mean, this is our algebraic equation. Uh, let's just it's too difficult to it's too difficult to do it by with the writing it down. Okay, so common denominator, so A S plus lambda 2 plus B of 2 factor. 1 plus B S plus lambda 1 plus C S plus lambda 2 equals to 1, right? Like that. S squared term is A squared plus B plus C is 0. The linear term is A times lambda 1 plus lambda 2 plus B lambda 1 plus C is also 0. And the constant term is 1. Right. Now, how do you solve it? The equation, 3 unknowns.
So give it minus lambda if it's minus lambda.
Which one did I?
No, if I see, I usually solve it like give S equal to 0, S equal to minus lambda 1, S equal to minus lambda.
You will set S equals 0.
Yeah, then we'll get value for A,
which is A lambda 2 lambda 1 equals to 1, which I get.
Yeah, so now set S equal to minus lambda.
Yeah. Yeah, we already have one. We already have one solved coefficient. Okay, that's better. That reduces to two unknowns. So A is regarded as known. So you only have two equations, and one thing to do is multiply by one equation and subtract by the other. So like if you multiply by lambda 2 here and subtract this, then that should give you, okay, this is done. Anything else? So lambda, multiply lambda 2 minus this one. So, and that cancel this term also. And so you get the minus number 1a. And this the 1 minus lambda 2. Lambda 2 minus multiply lambda 2. 3. And C cancel. B is A, lambda 1a, lambda 2, which is, we already have that, divided by 1 over lambda 2. Well, I got more. Lambda 2, right? Okay, now we're getting there. So C is the function space. C is minus A minus B is over lambda 2 minus over lambda 2 minus lambda. Okay, we got it solved. And then we just put in here and look up the inverse transform. The inverse transform of 1 over S is just 1, right? And this is exponential. This the inverse transform of this one is this one. The inverse transform of this one is this one. So, okay, so that I mean you can write it down, but I stop here. It's okay. This is just tedious algebra. How about other part? Find an approximate expression for lambda 2 and lambda 3 valid for small t and lambda 2. Lambda 1 is close to lambda 3. So that basically is a limit. That basically is a limit. And lambda 1 is close to lambda 2. So you have this two term. It's roughly the same, right? In the small time limit in t for small t, so this one, so exponential function. Let's say one of them numbers of 2t is approximately for small t. I mean, this is 1 minus t, right? And similarly for the other one, so then this implies that n2 would be 1 0, 1 minus number 2, and we're using this kind of approximation and subtract the 2, you get number 1 minus 2 plus t, because the constant cancel. So you cancel this 2, you get number 0. Right. So that's B, and C would be similar, right? Because you also have these two terms, except that we need to substitute all these coefficient in here and do the same thing, right? That should not be a problem. Okay, part C is to find the approximation for n2, n3 for large t under the condition lambda 1 much larger than lambda 2 or lambda 1 much greater. So for lambda 1 much larger than lambda 2, So this one is decay much faster. So you get rid of this one. So for lambda 2, right? And for lambda 3, for the other way around, it's just for lambda 2 much greater than lambda 1, you only have this one, right? So that kind of straightforward. Oh, yeah, actually, there's an answer. Okay, I suppose you that's the way it is. So for lambda 3, n3, for lambda 1 much greater than lambda 2, you don't have this term, you only have this term. And the other way around, lambda 2 much greater than lambda 1, you don't have this term, you only have that term. Yeah. I suppose that is the case. Yeah. All right. So that's okay. It's pretty straightforward. Once you get the answer right written out, and then just take the limit.